Hi everyone, this is Dr. Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So we are discussing about engineering typology subject. So in that part, the mechanism of various types of wear already we have discussed in the previous session. So various types of wears are there. So one by one already we have discussed. So remaining wear types we will see today's session. So already know about wear. It is a undesirable removal of solids from a sliding or rolling component. So it is not desirable removal of material. So somewhat quantity of material should be removed from the component, whether it is in sliding or rolling contact. So next types of wears, different types of wears are there. So last time we have discussed some wear types like abrasive wear and adhesive wear, fatigue wear. So remaining wears we will see in this session. So the types of wears, the erosion type of wear is very important in this typology subject. Why? Because every in the sliding contact motion, so suppose whenever two bodies are in relative motion, there is a friction and there is a wear. So whenever the high velocity of fluid is passed through the cutting grooves on a surface, then the hard particles contained in a fluid that creates some wear. So the cutting of grooves on a surface by hard particles. So due to the hard particles, some material scoring will be possible. That is called as erosion type. So how to prevent this type of wear? So mechanical part, remove abrasive materials by improved air and oil filtering. So whatever you are using the lubricant oil, first you filter it. And then any material is there in abrasive material in the fluid, so nothing but hard particles or foreign material, how to remove. So improved oil seals and flushing and frequent oil changes. Don't use old lubricants, old fluids repeatedly. Do not use. So due to this type of prevention is possible to reduce the erosion wear. Lubricant point of view, use oil free of abrasive particles. Next point, reduce some impact angle to less than 15 degrees. The impact angle is 15 degrees, so reduce this angle. Increase hardness of metal surface. The contacting surface hardness you can improve. And the lubricant point of view, use more viscous oil like SAE40 oil. The continuation of types of wears. The second one is polishing wear. So the continuous removal of surface films laid on a chemical reaction from an additive in oil or by very fine hard particles in the lubricant. Polishing wear is characterized by very shiny, very smooth, mirror-like metal surfaces Fine abrasives, so wear away the surface films as they form and report. So the polishing wear is characterized by very shiny and very smooth metal surfaces. The prevention is mechanically there is no particular method to remove this polishing wear. From lubricant point of view, choose less chemically active additive and remove corrosive contaminant. Remove abrasive materials. So these are the important points to prevent the polishing wear. Next one is contact fatigue wear. The cracking, fitting, and then spalling of a surface in sequence due to cyclic stresses in a contact. So the cracking. So whenever there is a crack on a metal surface, there will be fatigue wear, fitting also, and spalling is possible due to the cyclic stresses, cyclic repeated stresses. So loading and unloading conditions. The contact fatigue is most common in rolling element, bearings, gear teeth, and cams. So frequently rolling and frequently repeated operations. So example is gear teeth and cams. The prevention methods are reduce contact pressures and frequency of cyclic stress. So you can reduce the pressure, the contact pressure, and then frequency of cyclic stresses. The frequency, the applied load, the cyclic loads frequency, you can reduce. Use high quality vacuum melted steels. Use less abusive surface finish. Lubricant point of view, use clean and dry oil. Use more viscose oil. Use oil with higher pressure viscosity coefficient. So these are the points to remember to reduce the fatigue wear prevention. Next one is electro-corrosive wear. So the removal of metal by dissolution in a corrosive liquid with the aid of electric currents. So one surface of currents is the streaming potential from high velocity fluids. The oil serves as the electrolyte. So mainly this type of wear occurred due to the high voltage and current. The current values and then the voltage fluctuating values. So in this, the electrolyte is oil. The oil serves as the electrolyte. So in this process, some removal of metal is possible. So that is the phenomenon known as electro-corrosive wear. How to prevent? One is decrease liquid velocity and velocity gradients. First, decrease liquid velocity and then use corrosion resistant materials and then eliminate stray currents. Lubricant point of decrease or increase electrical conductivity of lubricants or hydraulic fluids. So decrease the electrical conductivity and then you can increase the electrical conductivity. That is depends upon the type of metal. Next one is fretting wear. Localized wear of lubricated surfaces due to reciprocating sliding of extremely low amplitude because of vibration. The localized wear of lubricated surfaces means so wherever the lubricant present, there the localized wear will be possible due to the reciprocating sliding of the component due to the vibrations also. So the prevention method is reduce or stop vibration by tighter fit or higher load. So apply higher load, or then you can minimize the vibrations by tightening the nuts and bolts of the machine. Improve lubrication between surfaces by rougher than hone. That is called as honing process. So improve the lubrication between two contact surfaces by a rough surface. Use oil of lower viscosity. Re-lubricate frequently. Use oxidation inhibitors in oil. Re-lubricate frequently. So already repeated this word. So use oxidation inhibitors and then use lower viscosity oil for this fretting wear only to prevent this type of wear. Next one is electrical discharge wear. In this type of wear, the removal of molten metal from surfaces due to the electrical sparks between them. So whenever high static voltages are developed by large rotating machinery, and these are relieved by sparking to regions of lower potential. So this type of wear is known as electrical discharge wear. The removal process is prevention is improve electrical insulation of bearings. Install brushes on a shaft. Improve machine grounding. Use of oil for higher electrical conductivity. Next one is cavitation damage wear. So in this type of wear, the removal of material due to the cracking and fitting caused by high energy implosions of various vacuous cavities in a cavitating liquid. So liquids cavitate when suddenly subjected to low pressure. Whenever these liquids subjected to low pressure, then cavitation is possible. Removal of metal by the vapor cavity implosion in a cavitating liquid. So the prevention method is use hard or tough materials such as tool steel, reduce vibration, flow velocity and pressures, avoid restriction and obstruction to avoid restriction and obstructions to liquid flow. The lubricant point of view, avoid low vapor pressure, wet oils, aerated oils always avoid, and use non-corrosive oils. Don't use corrosive oils. So by applying these methods, you can reduce this type of cavitation damage wear. So whenever you use hard material or tough metals, there is a reduction of the cavitation damage. The vibrations also. So suppose the machine is giving more vibrations due to the higher amplitude. First minimize the vibrations by tightening the bolts and nuts and by setting the various components. and reduce that type of velocities, flow velocity, pressure, low pressure and high pressure. So all these things leads to control this cavitation damage. So these are the important types of wears. So next, the classification of wear mechanisms. The wear process can be usually classified into three broad groups. So already we have discussed in earlier sessions. First one is wear by hard particles or liquids, wear by sliding and rolling contact, and chemically assisted wear. So wear by hard particles or liquids. So already we have learned in abrasive wear and adhesive wear, fatigue wear, and erosion wear. So all these things already we have discussed in previous slides. All these types of wears comes under this wear by hard particles or liquids. So include this category include abrasion, adhesion, corrosion, solid and liquid droplet erosion and cavitation erosion. So collectively, these accounts for nearly 80% of all wear related costs in industry. The second type is classification is wear by sliding or and rolling contact. The sliding wear is due to the two solid surfaces sliding over each other under some applied load. In most engineering applications, such as plain bearings or brushings, the surfaces are lubricated, in which case any wear that occurs is termed lubricated wear. So whenever two surfaces are in sliding, when applying load, there will be some friction and there will be some wear, that is sliding wear. Examples also already we have seen in earlier sessions. The sliding wear is often also called adhesive wear, which is somewhat misleading since adhesion between the sliding surface represents but one aspect of sliding wear. So next, adhesion is that well-known phenomena of this scupping and galling. These type do phenomena occur whenever I apply loads or whenever there is no proper lubrication. You are not supplying proper lubrication. There is a phenomenon of scupping and galling. So due to these two phenomena, the sliding wear will be possible. The characteristic feature of the sliding wear of metals is the occurrence of transitions in the rate of material loss as a function of sliding speed, applied load, and ambient temperature. So wear rates are low and the debris is formed by the wear process is typically finely divided and consists of a mixture of metallic oxides and continuation of sliding wear. With increasing loads and speeds, transitions occurs from mild to severe wear as a result of a change in the nature of the contact. So next type is rolling contact. This rolling contact wear occurs as a result of repeated applications of mechanical stresses. So example, cyclic loads, fatigue failure to the surface of one body rolling on another body. So due to the repeated applying loads, due to the cyclic stresses. It is most commonly found in components such as rolling, element bearings and gears and is characterized by pitting due to surface fatigue. So the fatigue process is exacerbated by sliding which often accompanies the rolling motion, particularly in gears, and applies additional friction stresses on the surfaces. Next, last one is chemically assisted wear. This chemically assisted wear refers to the material damage which is caused by the combined influence of wear and environmental attack, that is corrosion. So, in this, influence of wear and then environmental attack corrosion. So, first wear is due to the chemical reaction between these two contact surfaces or two metals. So, the rate of material, how much material removed, how much material loss happened, you can calculate the sum of the material loss rates due to the wear and corrosion, and these mechanisms act synergetically. You can calculate the rate of material loss, which is associated with the chemically assisted wear. So actually, it is higher than the sum of the material loss. Some material loss rates due to wear and corrosion. So these are the three classification of wear mechanisms and types of wears we have learned. So this is not unexpected since wear can accelerate corrosion by removing protective oxide films and exposing fresh reactive metal surfaces. So whenever the metal surfaces are exposed to the environmental condition, whenever you are removing protective oxide films, whenever reactive metal surfaces are there, then this type of wear will be possible. This type of mechanism related to so wherever associated with chemical reaction and then this oxide the films the protective removing and environmental attack corrosion. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.